do some taping. So here we go. We're talking about parabolas, and we're talking about quadratics, and we're remembering things that we've done before. This is right out of your course pack, the skills on page 201. Students will be given a snapshot of the skills learned in previous classes needed to be successful with Unit 2. Also, the unit project will be handed out, and skills needed for its completion will be taught throughout the unit. Polynomial vocabulary. For questions 1 through 4, granted you have more, that rhymed. Use the following polynomial: 3x to the 4th plus 5x squared minus 10x to the 5th plus 6x minus 8. Number 1, how many terms does the polynomial have? What is a term? A number or variable. What separates terms? Addition or subtraction. So looking at this, 1, 2, 3, 4, 5. This has 5 terms. Now, usually when we write a polynomial, we put it in standard form. Is this in standard form? No. Standard form means my exponents go down in degree from highest to smallest. Is this in that correct form? No. So if I was going to rewrite this, what would I start with? Negative 10x to the 5th. 3x to the 4th plus 5x squared, or 5x to the 2nd, plus 6x minus 8. Now that it is in standard form, question number 2, what is the leading coefficient of the polynomial? Negative 10. Without putting it in order, would negative 10 still be my leading coefficient? The answer is yes. You put it in order so it's easier to see that's my leading coefficient. Because it's in order, it's easy to see the degree of my polynomial. What is the degree of my polynomial? 5. It's the highest exponent value. It is to the 5th power. What is the constant term of the polynomial? What does it mean for something to be constant? It doesn't change, so does it have a variable in it? It's the part that doesn't have a variable. So my constant term is negative 8. So let's continue. All right, same objective. Let's take a look at some examples from your skills packet. We did the first 4 problems. Let's look at factoring. Let's look at problem number 8. There's 2 types of factoring that we will be looking at. The first type is taking out the greatest common factor. Does anyone remember what a greatest common factor is? Oh, you're so close, you're trying. It's the largest number and or variable that divides into each term. So look at your numbers, 7 and 21. What number will divide evenly into 7 and 21? 7. So part of my greatest common factor is 7. Look at your variable x squared and x. Stay with me, Ben. X squared and x. What's my greatest common factor of x squared and x? X. Y and y squared. What's my greatest common factor of y and y squared? Because I'd like to know. It's y. Now, what you're going to do which we don't always show you, is I'm going to take these two terms at the top and I'm going to divide them by 7xy. If I divide out a 7xy out of my first term, what am I left with? I'm left with just an x. The 7's cancel, the y's canceled, x squared is reduced to x. My operation plus stays right in the middle. 21xy to the second divided by 7xy, it reduces. The 21 divided by 7 is 3. The x's cancel. Y squared divided by y is y. Can I simplify anything else at this point? No, this is fully factored. I took out my greatest common factor. Pausing for station identification. Number 12. Number 12. Again, anytime you're given something and you want to factor, you want to look at your greatest common factor. 2y squared minus 10y minus 48. What is my greatest common factor of all three terms? 2. Again, we normally don't show the divide by 2 for each term, but that's what we're doing. If I take 2y squared and divide by 2, what am I left with? Y squared. Negative 10y divided by 2, what am I left with? Negative 5y. Negative 48 divided by 2 is negative 24. Thank you, Sean. I think Terrence gave me a previous answer. I'm not sure. Was that you, Terrence? Never mind. Can I factor any more? Yes. Yes? Yes? Maybe? So at this point, we need to unfoil when we factor. We need to ask the question, what multiplies to be negative 24 and adds to be negative 5? Is this possible to factor this out? This is factoring a trinomial. I have three terms, a trinomial. I want to factor this out. And there's different ways you've been taught to do this. Some people have seen the big giant X. How many people have seen this? Okay. I like to make a table. Some people have seen that from me, I know. There's different ways of doing this. The question is, what multiplies to be negative 24 and adds to be negative 5? Either way, you're asking the same question. What multiplies to be negative 24 and adds to be negative 5? If you need, list all the factors of negative 24. 1 and 24, 2 and 12, 3 and 4, 5, 3 and 4, 3 and 8, 4 and 6. Oh, sorry. But the ones that works is 3 and 8. Which one needs to be negative? The 8. Because 3 times negative 8 is negative 24. 3 plus a negative 8 is a negative 5. If the 3 was negative, you would get positive 5. And I put it on the wrong one up here. It should be a negative 8. That being said, fully factored, I have y plus 3 times y minus 8. That is fully factored. How do you know I'm not lying? There's a lot of people with degrees who lie. There's a lot of teachers who lie. Sometimes I'll lie to you just for the fun of it. But not right now, not while I'm teaching. How do you know that this is correct? What could you do if you really wanted to? FOIL it out. You could multiply it out and check. So let's do a check. First is y squared. Outer is negative 8y. Inner is positive 3y. Last is negative 24. Combine like terms. Distribute the 2. Is that what I started with? Did I factor it completely and correctly? Yes. Questions? Okay, let's move on. All right. So now we're talking about special, different kinds of factoring. What we just did was greatest common factor and basic factoring, where there's not a number in front of the x squared. Number 14, there's only 2 terms. I have x squared minus 36. Is x squared a perfect square? Yes, what? X. Is 6 a perfect square? Excuse me, let me try that question again. Is 36 a perfect square? What? 6. Is it subtraction in the middle? Yes. Therefore, this is my answer. This is called a difference of squares. When I FOILed this out, my 2 middle terms cancel, leaving a perfect square minus a perfect square. A perfect square minus a perfect square is factored out this way. How does this work? Why does this work? Because I'm unfoiling my original problem. If I was to FOIL this, I would get x squared plus 6x minus 6x minus 36. My middle terms cancel out, leaving a perfect square minus a perfect square. I'm recognizing that pattern and going backwards. It's called a difference of squares. You square root them both. The first one minus the second one, the first one plus the second one. It's always going to fit that pattern. Number 17. Well, this is very similar to the first problem, where I took out the greatest common factor of 2. But what's different of this trinomial? There's a number in front of the x squared, but it's not a greatest common factor. I can't pull it out front. I have to factor it. I'm sorry? Right. So how do I factor this? Okay, so this one, we use what's called the California method. This isn't the only way to factor a problem like this. This is a way to factor a problem like this. How many people have heard of what we call the California method? Okay, this is one factoring way. If I have a number in front of the x squared that's not a 1, what I need to do in my little table is I need to multiply a and c. What's 2 times 5? What's 2 times 5? Thank you. My b stays the same. And I ask the same question. What multiplies to be 10 and adds to be 11? 1 and 10. I can't write my final factors yet because when I undo factoring its FOIL, I have to have that 2 in front. I don't know if that 2, which factor the 2 goes with. So I'm going to start by putting 2 with both factors. And I'm going to put the 2 over the 1 and the 2 over the 10. Now, if I did this right, at least one of my factors will reduce. Do one of my factors reduce? Yes. 2x over 1, I need to leave it as a fraction because it becomes the factor 2x plus 1. It did not reduce. The only reason why we write in fractions is so that we can reduce. 2x over 10 does reduce to x over 5. So that's x plus 5. There are other methods to factor this kind of problem. At Chatfield, we have chosen to focus on this one. If you know or would like to see another, I would be happy to show that to you at a different time. There are other methods. If I FOIL this out, will I get 2x squared plus 11x plus 5? Do I need to show that to you? Yes, sir. No. No, I'm not. Yes, sir. You get the 10 by multiplying A times C. The first term times the last term. You always do that. If there's not a greatest common factor, you always do that. And that becomes the number it multiplies to. The 5 becomes one I add to. That stays the same. The B. Let's look at a couple more. The distance formula. This is not something we've done a lot in algebra. Where did you see the distance formula? Geometry. Woohoo! Gotta love that geometry. Who can tell me what the distance formula is? My distance is equal to the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. The difference of my x's squared plus the difference of my y's squared. Take the square root of it. No, because you cannot distribute square root over addition. They do not cancel out. It doesn't work that way. Okay? Think about it. The question was, does the square root cancel out the squares? If I square root 5 squared plus 1 squared, well, 5 squared is 25, 1 squared is 1. Is this 6? Or is this the square root of 26? The square and the square roots do not cancel. Sometimes they will reduce, but they do not cancel. So here we go. Let's do this. My distance is equal to the square root of 3 minus 2 squared plus 1 minus 4 squared. 1 squared plus 3 squared. Now wait, that's not 3 squared. That's negative 3 squared. Is that the same as 3 squared? Yeah, it's still 9. I cheated. Leave me alone. So this is the square root of 1 plus 9, which is the square root of 10. What's the square root of 10? About 3.0 something or 3.1 something. Do you remember the distance formula? I just wrote it down. Copy it down. Make sure you have it. Make sure you know it. Here we go. Here we go. Simplifying radicals, simplifying square roots, simplifying radicals, simplifying square roots. As a math teacher, we love exact answers. It's a very theoretical thing to have an exact answer. If you're doing an application, you want an approximate answer. But most mathematicians deal with exact answers. So I need to reduce these as best as we can without using decimals. So looking at the square root of 12, what is the square root of 12? Okay, that's not an exact answer. That's a decimal. Thank you. You have to ask yourself, what perfect square divides into 12? What are my perfect squares? What's 1 times 1? 2 times 2? 3 times 3? 4 times 4? 5 times 5? 6 times 6? 7 times 7? 8 times 8? 9 times 9? 10 times 10? 11 times 11? 12 times 12? 13 times 13? 14 times 14? 196, 15 times 15? 225. 16 times 16? Bam, good job. So here we go. The largest perfect square that divides into 12 is 4. So I can write the square root of 12 as the square root of 4 times the square root of 3, correct? What's the square root of 4? So this is 2 square root 3. Number 5. Number 5. Number 29. 5 square root 72. 5 square root 72. There are multiple perfect squares that divide into 72. Does 4 divide into 72? Yes. Does 9 divide into 72? Yes. What is the largest number that divides into 72? That's a perfect square. 72 is not a perfect square. There's a larger one than 9. Not 16. Not 15. Stop. Those aren't even perfect squares. That's not a perfect square. Now the 5 is still in front. Square root of 36. 36 times 2 is 72. What's the square root of 36? So this is 5 times 6 square root 2. 5 times 6 is 30. 30 square root 2. Now here's the thing. You're smart people. You're intelligent people. You can think. Yes. The square root of 36. So here's the thing, though. Can I write 72 as the square root of 8 times the square root of 9? Does that work? Yes. Square root of 9 is 3. Square root of 8. But can I reduce the square root of 8? As what? 2 times what? So this is 5 times 3 is 15. Square root of 8 is square root 4 times square root 2. But what's the square root of 4? 15 times 2? 30. Either way, do I come up with the same answer? Yes, what's the difference? One, I picked out the largest perfect square. The other one, I picked out a smaller one and had to keep reducing. Okay, guys, there's other examples, there are other problems that you have. Do the best you can. Come into class, check the video, do the best you can.